The invention of the optical telescope revolutionized humanity's understanding of the cosmos and significantly advanced the fields of astronomy, navigation, and science as a whole. From its humble beginnings as a simple refracting device to the highly sophisticated observatories of today, the optical telescope has undergone a fascinating evolution. This description delves into the history of optical telescopes, exploring their origins, technological advancements, key discoveries, and their profound impact on society and science. The roots of the optical telescope can be traced back to ancient civilizations, where lenses were used to magnify objects. Early lenses, made from polished quartz or glass, were primarily used as reading aids or magnifying tools. However, it wasn't until the late 16th century that the first true telescope was invented. The invention of the telescope is often credited to Hans Lippershey, a Dutch spectacle maker, in 1608. Although Lippershey filed the first patent for a spyglass, it is believed that other craftsmen, including Zacharias Janssen and Jacob Medius, were developing similar devices around the same time. These early telescopes, known as refracting telescopes, used a combination of convex and concave lenses to magnify distant objects. Their magnification was modest, but they marked a significant step forward in optical technology. In 1609, the Italian scientist Galileo Galilei heard of the newly invented telescope and built his own improved version. Galileo's telescope had a magnification of about 20x, which was a considerable improvement over earlier designs. With this instrument, Galileo made groundbreaking astronomical observations, including the discovery of the 4 largest moons of Jupiter, Io, Europa, Ganymede, and Callisto. The observation of the phases of Venus, providing evidence for the heliocentric model of the solar system, the detailed study of the moon's surface, revealing craters and mountains, and the observation of countless stars in the Milky Way, previously invisible to the naked eye. Galileo's work not only demonstrated the potential of the telescope for scientific exploration, but also challenged long-held beliefs about the cosmos, sparking controversy and advancing the scientific revolution. The refracting telescope dominated the field of astronomy throughout the 17th century. However, it suffered from a significant drawback known as chromatic aberration, where light of different colors failed to converge at a single focal point, resulting in blurred images. This limitation led to the development of alternative designs. In 1668, Sir Isaac Newton addressed the issue of chromatic aberration by inventing the reflecting telescope. Instead of lenses, Newton's design used a curved mirror to collect and focus light. This eliminated chromatic aberration and allowed for clearer images. Newton's reflecting telescope was compact and efficient, paving the way for future advancements. In the mid-18th century, Chester Morehall and later John Dollond developed achromatic lenses, which significantly reduced chromatic aberration in refracting telescopes. These lenses combine 2 types of glass with different dispersion properties, correcting the focus for multiple wavelengths of light. This innovation revitalized interest in refracting telescopes and led to the production of higher quality instruments. The 19th century saw significant improvements in telescope design and construction, driven by advancements in optics, materials, and engineering. During this period, larger refracting telescopes were built, culminating in the construction of the Great Refractor at the Lick Observatory in California and the Yerkes Observatory in Wisconsin. The Yerkes refractor, completed in 1897, remains the largest refracting telescope ever built, with a 40-inch diameter lens. Reflecting telescopes also saw significant advancements. The use of silver-coated mirrors, introduced by astronomer William Lassell in the 1840s, improved the reflectivity and durability of telescope mirrors. Later, the advent of aluminized mirrors in the 20th century further enhanced the performance of reflecting telescopes. The 19th century also witnessed the birth of astrophotography, which transformed the way astronomers studied the universe. Pioneered by figures like John William Draper and Henry Draper, astrophotography allowed for long exposure images of celestial objects, revealing details that were impossible to observe visually. This development marked a shift from purely observational astronomy to the systematic recording and analysis of data. The 20th century brought about a revolution in telescope technology, driven by advancements in physics, engineering, and materials science. The construction of large reflecting telescopes dominated the 20th century. The 100-inch Hooker telescope at Mount Wilson Observatory, completed in 1917, played a pivotal role in Edwin Hubble's discovery of the expanding universe. Later, the 200-inch Hale telescope at Palomar Observatory, completed in 1948, became the world's largest optical telescope for decades. The development of adaptive optics in the late 20th century addressed the problem of atmospheric distortion, which blurred images captured by ground-based telescopes. Adaptive optics systems use deformable mirrors controlled by computers to correct for atmospheric turbulence in real time, significantly improving image quality. One of the most significant advancements in optical astronomy was the deployment of space-based telescopes. The Hubble Space Telescope, launched in 1990, overcame the limitations of Earth's atmosphere to provide unprecedented views of the universe. Hubble's discoveries, from distant galaxies to the birth and death of stars, have transformed our understanding of the cosmos. In the 21st century, the quest for ever more powerful telescopes continues. Ground-based observatories, such as the Extremely Large Telescope, ELT, under construction in Chile, aim to achieve unprecedented resolution and sensitivity. These instruments incorporate advanced technologies, including segmented mirrors and adaptive optics, to explore the universe in greater detail. Space-based telescopes, like the James Webb Space Telescope, launched in 2021, extend the capabilities of optical astronomy into the infrared spectrum, enabling the study of the earliest galaxies and the atmospheres of exoplanets. The optical telescope has profoundly influenced science and society. By expanding our view of the universe, telescopes have confirmed fundamental theories, such as the heliocentric model and the theory of general relativity. They have revealed the vast scale and complexity of the cosmos, fostering a sense of wonder and curiosity. They have contributed to practical applications, such as navigation, timekeeping, and satellite technology. Moreover, telescopes have inspired generations of scientists, engineers, and the general public, highlighting humanity's enduring quest to understand our place in the universe. The history of optical telescopes is a testament to human ingenuity and curiosity. From their origins in simple magnifying devices to the sophisticated instruments of today, telescopes have continually pushed the boundaries of what we can observe and understand. As technology continues to advance, the next generation of optical telescopes promises to uncover new mysteries and deepen our appreciation of the universe. The journey of the optical telescope is far from over, and its future holds endless possibilities for discovery and exploration.